All right, so this is Workplace 30, and we are on part 2 of section 1.2. So in your workbooks, if you're following along with me on page 41, we're talking about equations of partial linear relations, right? So we've been talking about direct linear relations, and the direct linear relations would be y equals mx, right? You remember that from the last lesson? Now, partial linear relations are very, very similar. They're y equals mx, and then there's a plus b there, okay? Now, this one is when we really have a y-intercept of 0, so it's kind of like adding 0. Y equals mx plus 0 is the same as y equals mx, right? So the cool thing about this is the b value, this constant, is the y-intercept. So this is direct. Okay, the direct linear relationship, because really we have a plus 0 on the end here, see? This, if b is anything other than 0, then it is a partial or indirect. I guess I say indirect a lot. They call it partial, which is great. That's fine too. Okay, so the y-intercept is the y value of the point where the graph of the relation intersects the y-axis. So let's say that this is an axis here, okay? If this is a straight line and it intersects the y-axis here at this point, this is the value of b. So this is b right here, okay? And a direct linear relation would look something like this, where the line goes through 0, 0. And that's, of course, b equals 0 there. All right, so direct linear relationship and partial linear relationship.
So partial is not in the origin?
Partial just means it does not pass through the origin. Exactly. Yeah. So think about this. Y equals 12x plus, let's say, 30. And let's say this is a description of the flat fee that you have to charge for someone coming in to take a look at your sink, a plumber or something. And this is the dollars per hour. Now these numbers might be a little bit low if it's a licensed plumber, journeyman plumber. But let's just say this is the flat fee that they charge it initially, and this is the dollars per hour. Well, here is the flat fee, 30 bucks. And then each hour you add 12 more dollars to the bill, right? So that 12 is the rate of change. It's the dollars per hour. And the $30 is just a flat fee of 30 bucks that's at the very beginning. So when it's at the very beginning, that means it's not 0, 0 at the very beginning, right? It actually starts at 30. Okay. Let's take a look at example 4 real quick and see what type of question they're asking here. Write an equation for a line with a slope of 5 and a y-intercept of 6. And what is the value of y when x is 5? So there's two parts here. So remember, we're starting off with this very important equation here, y equals mx plus b. The m is the slope, we know that, and now we've learned that the b is the y-intercept. So if you simply substitute values in there, you get y equals 5x plus 6. Let me write that a little bit bigger. There's your slope, and here's your y-intercept, positive 6. Everyone good with that? Now this second question is really important. What is the value of y when x is 5? So really, let's put in an x equals 5, and then we'll solve for y, right? We don't know what y is. So it kind of looks like this. Y equals 5 times 5 plus 6. That's 25 plus 6. Y equals 31. So when x equals 5, y equals 31. Or the point 5, 31 would be on the graph, okay, would be on the line. All right? So I don't know if we need to do the second part of that. Let's do number 7 from scratch together, and just so we can see what we're doing. All right, so write an equation of a line with, so remember, we're remembering y equals m times x plus b. That's our format, and we're going to try and figure out if we can find out what m is and find out what b is, and then just substitute values in. It's pretty straightforward. So this one has a slope of 6. They give you a slope of 6. So let's write y equals 6 x. Remember, don't change the y and x when you're writing an equation of a line. Leave y and x as themselves. It's the m and the b that you want to try and work with. Now there's a y-intercept of -5, so if we add b, we're adding a -5. So just so you know, the shortcut is whatever b is, you just write it right here at positive or negative. So this would be 6x minus 5. Y equals 6x minus 5. Right there. Okay? Let me just maybe move that for you over here. Okay? Anybody have questions about that one? Are you good with that? You understand that? Know why I did that? Okay. I tell you what, why don't you take 20 seconds and do B, and I'll show you the answer in a second. Okay, so do B there. Write the equation given the slope of 3/4 and a y-intercept of 15. So you can look up at the board when you've had a chance to do that. This one's pretty easy. 3/4 goes in for M, and 15 goes in for B. Just like that. Yeah.
If we put it into a decimal, would that change it?
You wouldn't have to put it as a decimal, but if you wrote y equals 0.75x plus 15, that's good too. That's okay. Yeah, that's all right. Okay, let's do number 8 together. Okay, number 8 says, write the equation of a line with a slope of -5 and a y-intercept of -3. Okay, let's stop right there. Well, that's going to be y equals, m is -5, so -5x, and then plus a -3 or just -3. That's the equation. What is the value of y when x is 3? Well, we did one just like that as well. So when x equals 3, I'm going to do this right here. Y equals -5 times 3 minus 3. I'm just going to substitute that in, and I'm going to get y equals, let's see, -5 times 3 is -15 minus 3. Y equals -18. So there's our two pieces, or the two answers to this question number 8. Okay, so for number 9a, this is your equation. 12.5 is your slope, and 25.5 is your intercept. For b now, what's the value of y when x is 10? Well, if we have y equals 12.5 times x, let's substitute 10 in for x. Now, is that the right equation? Did I just make sure I remember here? 12.5, 25.5, okay. So we simply put in 10 in for x, okay, and then multiply everything out and go from there. So this is going to be 125 plus 25.5. That's going to be y equals 150.5. Okay, so I don't know if many of you are at this stage yet, but again, so for this last one actually, what's the value of x? So that's what we don't know. We don't know what x is when y is 213. So you put 213 in place of the y here. See that? And then you don't know what x is, so you leave x as unknown. 25.5. So that's how you set up letter C. Okay? So I'm going to leave that with you for C. If you want another minute to finish that, because I think some of you aren't done that, but you guys finish that on your own, then we'll talk about example 5 in a minute, okay? So moving on here, example 5 is another type of question, and we'll take a look at example 5 here. It says Vikram is planning a banquet dinner. The caterer charges a flat fee of $150. Okay, that's pretty important. A flat fee. That's where the charges begin. Flat fee of $150, and then $420 for every 10 people. That seems to be like a rate. That seems to be like it might be a slope. Okay, flat fee seems to me like that's going to be a b value. Dollars per person, that seems to me like it's going to be a slope. All right, so that's what you want to identify here. Now what they've asked you to do here, and again, we won't do this, but we'll just take a look at their solution. But if you were to make a table of values representing the cost of 10, 20, 30, 40, or 50 people, then this is what you would do. You would take $450, 150, sorry, flat fee. So 150 flat fee, plus for 10 people, it's $420. And that's where you get 570. For 20 people, it's 150 flat fee plus 2 times 420. See that? Yeah, you could add 420 each time, but this is how you get the number from scratch. And the reason why I'm doing that is because look at what this looks like. Y equals 150 plus 2 or plus however many groups of people, groups of 10 people, times 420. Doesn't that look like an equation there? It does. It looks like an equation. Y equals 150 plus x times 420. Right? That's x per 10 people. Or y equals 420 per 10 people is a slope of 42 times the number of groups of 10 plus 150. So I'm just kind of showing you how when you generate these numbers, there is a pattern to how you generate them. When you add 420 each time, yes, that's how you can get the numbers down the list. But in order to find the equation, you're going to try and find out a pattern that looks like an equation. And this kind of looks like an equation. The cost equals, right? So anyways, so that's what I was just trying to show you. So it says, what is the slope of the graph? Well, the slope of the graph would be the rate of change, and that would actually be 420 divided by 10, or 42. And that represents the total cost per people, per person, per people. The cost per person. Okay? Dollars per number of people. Dollars per people. What does the y-intercept represent? Well, let's take a look at the graph. Okay, here's the graph of what we've gone so far. The y-intercept would be somewhere around here. Now, what would this y-intercept represent? What did we say there? Yeah, it would represent the flat fee. Okay? The slope represents the cost per person. The $100, $150 is the flat fee. Okay, so it says the C says, or D says, what is the y-intercept and what does it represent? Well, this might be a bit tricky. If you just wanted to extend the line, you might not be able to get to exactly 150. But if you understand the question, then the flat fee is 150, which is the same as the intercept. So what they did was they picked an x value and a y value and the slope, and they solved for b. So this is really good as well. Okay, they solved for b. So for 10 people, the cost was 570. The slope is 42, and now the only missing thing is b. That's how you would solve that algebraically. Okay. And then finally write an equation that represents the relationship. Well, we kind of did that already. And I think that's going to be, where was it? Y equals mx plus b, so y equals 42 times the number of people x plus 150. Okay, any questions with that? Okay. All right, so let's do part of this question here together. See if we can do it. And I'm going to be asking you for answers. So let's see if we can get this. A Get Fit fitness center charges $75 to join, then $25 per month. So which one of these would be the rate of change? The rate. Yep, this one right here. 25 per month. That's going to be the M. 25 per month. Months is going to be X, and 25 is the rate, the dollars per month. What is this part right here? 75 is going to be the, what letter goes here with the 75, or what part of the equation? B, correct. That's B. Awesome. So we've got we already know the equation, and that's down here, I guess. Write an equation. Y equals 25x plus 75. Okay? So 1, 5, and 10 months. Okay, let's make the months down here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let's see. This is cost, and this is months. Let's just make a little table of values here. Actually, I probably should put that the other way around, because the months are going to be our x. Months and cost. Have you ever seen months represented by MO? Point S. You seen that? Okay, so 1 month. What's it going to cost for 1 month? After 1 month, so we've got 75 plus 25. See that? So after 1 month, it's going to cost $100. I don't know. Maybe we should put $100 right here. 1 month is $100. Everyone see that? Let me just write a little bit more detail here. Months, and this is going to be cost in dollars. Canadian dollars. Or it could be US dollars if you want. Or euros. 2 months. Well, 2 months is going to be 75 plus 25 times 2, right? What's that going to be? 125. Okay. So after 5 months, oh, my scale is going to be a little bit, this is going to be a bit tough. Okay, so here's lesson number 1. I assumed $100 should be here, but you know what? 100 should have been up here a little bit more, because after 5 months I'm only at 125. Look at it doesn't move much. I'm not going to use much of my graph. So at this point, what you would do, because you're using a pencil, is you're going to change this now. You're going to say, oh my goodness, let's figure out, 5 months. What? Nobody caught me. This is supposed to be 5, guys. Sorry. I thought it was 1, 2, and 10. 5 months. My bad. So let's get this right. 1, 5, and we got to do 10 over here too. So before we plot the points, let's just find out what numbers we're using here. So 75 plus 25 times 5. Okay. So 75 plus 125, that's going to be 200. And you can just do that in your calculator if you can't do it in your head. That's fine. Okay, after 10 months, we've got 75 is your original plus 25 times 10. So what's 250, because that's 25 times 10, plus 75, what's that? 325. Very good. Okay, so these are the numbers I need to fit on there, guys, right here. Okay. So I can go from 1 to 400 really, or whatever. So I could go 1, 2, 3. Let's do 4 squares for 100. 1, 2, 3. There's 200. 1, 2, 3. There's 300. And then that's 325. Okay, so whatever. This is 375 now. Okay, sorry, that's getting a little busy there, but we've got our numbers here. 1, 2, 3, and 375. Okay. So 1 goes with 100. That's going to be up here now. There we go. 1 month, $100. 5 months is 200. 5 months, we're going to go up here to 200. See that? And then 10 months is 325. So it's 325. Okay. Draw a graph, show the cost. Okay, awesome. So those are the 3 points. Now, this looks pretty linear, doesn't it? So if I were to draw a line through these points, kind of want to, there we go. Okay, awesome. Oh, that's perfect. See, now look at, where does this line end up hitting the y-axis? 25, 50, boom, 75. See that? So this is a partial linear relation. We have a y-intercept that's not 0, 0. We have a y-intercept that's 75, which represents the money you owe before you've spent any time at the gym. The flat fee. Okay? Is all this sort of lining up for you? Is this making sense? Yeah? Is this easy? Have any questions about this? Anything going like, don't quite get that? All right, 9 months. So how do we figure this out? Well, what you can do is you can say, hey, where's 9? Well, 9 is right here. So let's go up until we hit the graph. Oh, and look at, this is the money for 9 months. So what is that going to be? That's going to be 300. Look at that, 9 months, according to this line, 9 months is going to be $300, okay? And that's straight from our graph, and you showed your work there on the graph. All right? Okay. So that's it for that question, I guess. Now there is going to be number 11, but I think what we're going to do is we're going to try, and I'm going to do this last example today, okay, for the rest of our lesson here. And the last example, and then you're going to have some time to work on these, build your skills later, okay? So let me go over this one last example with you. So Charlie wants to add a long distance plan to his cell phone plan. He's comparing two options. Option 1 is a rate of 25 cents per minute, or $0.25 per minute. Option 2 charges a flat fee of $5 a month plus 10 cents per minute. Write equations representing the two long distance plan options. Okay, so for option 1, option 1, it's going to be, there's no flat fee, so this is just cost, or y, equals $0.25 per minute. And I'm going to use cost and minutes here, C and M. All right? So that's your option 1. Option 2 goes like this. C, the cost is 0.10 per minute, but plus $5 every month. So obviously, if you spend a lot of time on the phone and your minutes are high, this might be a better deal because you're spending less per minute. But if you don't use a lot of minutes and you don't want to pay this $5 flat fee, you might be able to get away with this one, right? So there's things that you want to consider. But the neat thing about this is when we graph these, I don't know if they're going to ask us to graph them, but we can kind of see which plan is better given how many minutes you plan to talk.
Did you also do the equation?
Well, we've done two equations here. Yeah.
Which would be the equations that John grabbed?
Do the equations what? Sorry?
That John grabbed?
Well, yeah, there's different things you can, let's see what the question asks first, okay? Let's see. So write equations, got it? If Charlie uses 50 minutes of long distance per month, which option is cheaper? So if we're given a number, yes, we can plug it right into the M for both and find out which one is cheaper, right? And so 50 minutes here, so the first one is going to be C equals 0.25 times 50, and the next one is going to be C equals 0.10 times 50 plus 5. So when we work that out, what's that going to be? About 1250? Okay, check on your calculator for me. And this one here is going to be, what? $10, I believe. Okay, so let's just check to see which 50 minutes are used. Let's see what they say. So 1250 and 10, yes. So we plug our number of minutes into each equation that we've made, and then you can quickly calculate your cost. Any questions about that, guys? Okay, so the final type of question there, the final question that's asked here is, how many minutes of long distance would Charlie need to use for both plans to be the same price? Now, two ways you could do this. You could let each equation, let the two equations equal each other and find out where they cost the same. Or, and this is what I was mentioning about the graphs, watch this guys. The first graph, the 25 cents per minute graph, is going to look something like this. The slope is going to be quite high, but it's going to go through 0, 0. The 10 cents per minute one is not going to be as steep a slope, but it's going to start up higher. It's going to start like this. So this is what the graphs would roughly look like. And this point right here, this number of minutes would be where they cost the same. If you use less minutes than this, this first one's going to be cheaper. If you spend more minutes, then the other one's going to be cheaper. You see that? So this is the way that they did it. They let each equation equal each other. Both equations equal each other. And they solved for n. And here n is approximately 33 minutes. The other option, method 2, would be to graph them and find out which m value they intersect at. And again, this would be about 33. Okay? So I'll just one more thing that I'll say is because both of these are costs, right? They just let this equal this and solve for m. That's how they did it algebraically. Graphing might take a little longer, but you can do that as well. You can plot the points and connect the dots, and then wherever they intersect, that x value, or in this case m value, would be the number of minutes where they both cost the same, because this is the cost for both of them at that exact minute. Okay? Any questions? All right. Well, let's just take a look at 13 together here. I'll get you started off on this one, okay? 13. Gina is a car salesman. She earns $750 per month plus 4% commission on her total sales. Complete the following table showing Gina's income based on the following sales totals. So she makes $750 per month plus 4% on her sales. So the earnings over here would be $750 plus $10,000 worth of sales times the decimal form of 4%. And the next one would be very similar, except you use the different value now. Same 4%. And then you could calculate her earnings for those 3 months. So that's how you do A. All right, so let's take a look at B together. Hopefully you filled up those numbers for that chart. Let's take a look at B. It says write an equation that shows the relationship between Gina's income and her total sales. Okay? So we have y equals mx plus b. What's the slope? What's the slope? So look again at our calculations here. What's the slope? What part of these equations would be the slope, do you think? Anybody? The slope is 750. Do you know, it does look like this is a rate. I'll agree. But this is more like a flat fee every month. Like it's just a base amount, right? So a base salary. See, look at this. See, this is the B here. That's the B. This is the M. That's the slope. That's the rate. It's 4% is the rate. So if you look at this, it's kind of like, you know, a dollar value times, or actually we should write it like this. This will look more familiar. A rate times a dollar value, and then plus the base salary. See, now it kind of looks like y equals mx plus b, right? That's what I was getting at. So m is 0.04. The b would be the 750, the base salary per month, which really isn't much, is it? It's really not much at all. So the equation then is y equals 0.04x plus 750. Now, how much would Gina earn if she sold $100,000 worth of cars? Wow, that's a lot. So let's see. Well, now instead of filling out our table, we could just use our equation. So we have 4% of 100,000, right, plus 750. So her earnings, which would be Y, I guess, her earnings would be so 4,750. So that's her earnings if she sold $100,000 worth of cars. And now D, okay, D says this: if her basic salary was reduced to $600, but her commission was raised to 5%, would Gina make more or less on the $100,000 in sales? Well, we could pretty easily and quickly make a new equation. What does the new equation with these values look like? Here's the old equation for her earnings. What's the new one look like? Anybody? What do I write here? You guys know over here?
Would it be y equals 6% x plus 600?
Well, this is actually, this is 5%.
5, sorry.
So this is 0.05x. And then plus, what would this be? Plus what?
Plus 600.
Yeah, plus 600 would be her base salary. Very good. So that's the equation. And of course, if we put $100,000 in here, you're going to get what she would earn, right? So we put this 100,000 in for X. Okay, so I think you can take the rest on your own there. You can do D, finish D and E, and then 14 as well. So I'll get you to work on the rest of your build your skills that you haven't done all the way up to 14 for tomorrow. Okay, so build your skills up to 14 for tomorrow.